I would like to demonstrate API Center service and capabilities that it offers. I will be demonstrating this on limited preview version that would be live by 19th of December this year and available on request basis. The service will offer improved and enhanced capabilities with multiple releases planned throughout the next year, which is 2023. During this demonstration, while I'll talk about the capabilities available with limited preview, I will also point out what else you can expect in 2023. With this, let's log into the IDMC environment. You will notice a new application, API Center, available under the list of available services. Clicking on this will take you to the API Center Explore page, which we should see shortly. There you go. So you get to see the API Center Explore page where you can browse through the IDMC assets. They are arranged through projects and folders. I'm going to create a new project called Preview Demo. And I'm going to create a folder inside Preview Demo called Demo1. This is what we're going to use as a workspace for our demonstration today. So first things first, API Center service provides role-based access based upon various personas that can access the service to accomplish the task that we expect of them. For example, API Policy Manager role. It allows the creation of enterprise-wide policies that can be used by the APIs authored on API Center, and that we will see shortly in the demonstration. This means access to the policies page, but that's all they can access. Users having API Designer role can author APIs. They can do so by clicking on the new and create a REST API. Similarly, API Monitor and the API Deployer role, they allow user to access API Monitor and API Console pages respectively. One can create users on API Center. So one can create users on API Center based on their requirements and practices to allow usage of various components of API Center. And then there is an admin role which allows you to exercise all these given capabilities. This is what I have used to log in, and so you see all the features available to this role. All these roles are part of the IDMC user and role management. I'm now going to create a new REST API by clicking on New and REST API. In the future, you'll see more API types such as SOAP API, GraphQL API, Async API, on OLT API as well. So let's click on Create. Well, creating a new REST API is made simple by just filling up the details in the form rather than using difficult to work with Swagger editors. So note that every API has a name. I'm going to create a new order API, so let's give it a name. There's a location, then there's an API name, which I should just put as the API name given above. Optional description. And a version. If I try to save this API, it will open up the validation panel, which will let me know what errors I have been making in the API creation. For example, I've not chosen a location yet, so I get to see there's an error in the validation panel. So let's provide a location. I'll choose the location as what we have just created, which is the demo1 folder in the project preview demo. If I save it now, it will all work fine. Well, in general, REST APIs can be lamely described as a collection of operations or actions, where each operation documents a very specific task. So rather than asking the user to start coding all these operations manually, which you can do so by clicking on the plus sign and define these operations, user can borrow these operations from existing REST API contracts and make updates to fit their requirements. So in this demonstration, like I mentioned, I'm going to create order API, and so we'll borrow some operations available from the pet store API, publicly available on the live location. I can do so by clicking on import, either here or from here, providing the format, which is Swagger 2.0 JSON. It's a URL, so I give the URL here. Click on next. And then I get to see all these operations that are available as part of this API definition. So I'm going to choose some operations from this list. For example, place order, get order by ID, and I'll choose delete order. And click on next. You see a comprehensive summary over here. You click on import and you get all these operations listed here. I can still go ahead and import more operations from other specs to make progress in my API design. Let's import another one. Let's save this first. Click on import. This time I'm importing an OpenAPI 3.2 JSON spec, which is a file-based spec. So I can choose from the file locations here. Click on next. From this spec, I'm going to import create sales order operation. Click on next and import it. And there you see it. This is also available. Let's click on save. And the validation panel shows different errors right now in the API design. And we'll talk about that. Like I mentioned earlier, you can author new operations by clicking on the plus. And if that suits your requirements, you can do that. For now, we will just delete this operation. Now let's look at one of these operations. Let's look at the place order operation. Place order is the name of the operation, which you can change if you need to. There's an optional description here. This is to place an order. You can see verb types. It supports get, post, put, delete, and patch. This is a post operation. You can see the endpoint. You can define path or query parameters here. Okay. For example, if I were to look at this operation is a path parameter. This one is a path parameter. This one is a path parameter, which you can also put in your endpoint URL. Any update which you make to an operation would be evident through a small blue dot here, so you don't never lose your work. You can view and add request headers as well as request body. You can represent or update the request body in tabular format, for example here, or you can update this in JSON format where you can copy an existing schema here. You can make changes to it. For example, in this case, I'm going to change the pet ID to name. I'm going to make it a type text. You can make all these changes. These two formats are interchangeable. You can add more fields if you need to by clicking on the plus operation here. You can define more request headers here. You can define complex types. For example, in this operation, you have a complex request body, right? If I go back to place order, here is your response. Let me also update the pet ID here to name of type text. In limited preview, we're only supporting one status code, which you can see here. You can change the status code if you need to. But in the upcoming releases, this will be extended to allow multiple response codes. For now, you can update the response code to your liking. In this case, I'll just keep it tuned OK. Now let's talk about the implementation tab. This is where you identify and attach an implementation that fulfills this operation. In the limited preview, we are starting off with app integration process as the only implementation provider. But in the upcoming releases, this would be expanded to include other IDMC providers such as data integration task flows and non-IDMC third-party providers. Now that's a distinct privilege that you have when you choose IDMC implementation. You can generate a new implementation stub in addition to mapping an existing implementation. You can generate a new implementation for this operation providing a name. So in this case, let's give a name, place order process, and a location, which again, I'm going to choose the same folder, which is my current workspace, and an optional note to the API implementer. And click on generate. Behind the scenes, it's creating a cloud app integration process. This is a step process. Once this is generated, you will notice that there is a mapping provided wherein your process inputs are assigned values from the API request, and similarly, your process output feeds into your API response. If you want, you can change them or you can keep them as is. These are all auto-mapped, so which makes your life a bit more easier. You would also notice that once the process stub is generated, the choice changes to map existing, and the process exists now. You could choose any other process as well by clicking on Browse. You get to see all the processes available in your org, and you can choose any of them. At any point in time, if you want to refresh the implementation because the implementation has changed, you can do it by clicking on Refresh. It will still do an auto mapping based upon the name. Now let's look at the generated process. So for this, I'll go into App Integration Environment. Go into the right folder, which was Preview Demo, and the folder name was Demo1. You will notice that we have already created an app integration process, which is in published state. Let's look at this process. You notice that this is an anonymous process, and the input fields match what we have defined for the API request, and so does the API response fields match the process output. I'm going to make some updates to this process so that this is not just a stub anymore. I'm just going to assign the name of the item in the input, the name of the item in the output, but you can do much more here. I'll click on Save and publish it. Now let's get back to API Center. With limited preview, we allow name-based matches only. Because today we don't support payload transformation, but that's going to be coming in the upcoming releases. Once you have that, you will be able to assign not just by name, but based on type, add more status code, for example, in the response tab, and perform content-only and formula-based assignments. If I try to save an API which does not have implementation for any operation, it results into validation error because there is no implementation for an operation. We will relax this in the upcoming releases. So let's create new implementation for existing operations as well. I'm going to delete the create sales order operation because I don't need this for my API design. And for others, I'm just going to create a stub application process that is used as an implementation. So I'll call this get order by ID process. Give it the location of our workspace. Generate. And I'm going to create something similar for the delete order operation as well. Click on save, and now there's no validation error. Now, before I move on with other aspects of API design, I want to show you how API Policy Manager can let you define enterprise-wide policies that the API designer and deployers can use. So if I go to the policies page, you can define those policies there. Now today we support 4 types of policies as reusable policies here, and this list will become longer in the future. We categorize policies into 3 buckets: security policies, operational policies, and the privacy policies. Security policy currently has only authentication policy. So let's try one of them. With this policy, you can enforce the rules of access by the API consumer. You can choose the policy to allow anonymous, basic, OAuth, or Jot. You can either choose anonymous or you can choose any of these 3. You can define OAuth client under configuration page by following wizard-based approach. This eventually leads into getting an OAuth client ID, OAuth client secret, and auth header value, which you can save for future purpose. Let's get back to the policies page. You will notice that there is a reference against every policy. This indicates how many API operations are referring to a specific policy here. Let's talk about the operational policies. There are two types of operational policies: rate limiting policies and response caching policies. Let's create a rate limiting policy. With rate limited policy, you can control the number of times API consumer can access the operation during the design time frame. So in this case, let's allow only 3 requests in 60 seconds. I'll save it. And there you have your rate limiting policy as well. On similar lines, you can define your response caching policy as well. You can reduce redundant backend load by creating response caching policies for operation. So you can say the cache is only valid for 60 seconds. You can save this policy, it's already enabled. And then there is a privacy policy. So let's define a privacy policy. This allows you to configure on how you want to protect personal identifier information, PII, that API data might contain. So API Center can issue warning or block API requests and responses if the request or response payload contains credit card numbers, email address, IP address, phone number, or US Social Security number. Let's continue with our API design. At the API level, you can define security and privacy policies. These are the policies that your operations can inherit. You can either use none if you don't want to apply any of these policies, or use existing policy, in which case you are shown the list of reusable policies, or you can create a new one in the scope of this API itself. You can also put notes here. These are optional, but they indicate the intent and why the policy was chosen. This will act as a guidance to API deployer when they operationalize the API. Similarly, you can define the privacy policy as well. I'm just keeping the none for the case of the demo. Going back to the design, if you go to the policies tab for an operation, you can define the policies you want to apply on this operation. This is just a guidance for the API deployer, since we are still designing an API, not operationalizing it. You can choose to inherit from an API level policy that we just spoke about, or use none, use existing, or create a new policy. Very similar to the way you did for the API level policy. You can only inherit the security and the privacy policies, as they are mostly API wide. Again, optional notes that you can provide that can be used by the API deployer during deployment. For this demo, I'm going to use an existing rate limit policy. This policy, if you remember, we mentioned this allows only for 3 requests per 60 seconds. Let's save the API design. And then there is a configuration tab, which lets you configure response timeout for this operation. So with this, our API design is now complete. You can go ahead and publish it. You need to provide the publish comments when you're doing a publish, along with the API name, with which this will be made available in the API registry as a published API. These are revisions, so I'm going to give this as a revision 1 suffix and publish it. Subsequent publishes of an API after you make changes in the design. For example, let's put a new description, save it, and again do a publish, and this time I can call this revision 2 and publish it. Each of these published versions are made available in the API registry as published API. The API name with which we published helps distinguish between various revisions of the API. While API revisioning is already available with limited preview, API versioning will be upcoming in the future releases. Let's go to the API console now, which provides you the view of all the published APIs and the managed APIs. So after publishing the API, you can see the entry for this under designed API name, like this one. You would notice that we created two revisions of it. We did two times, we published two times, and there were two revisions created as part of that. You see both the revisions here. You would notice that we don't allow any action on the first revision, which was the old revision, but we do allow an action called create a managed API on the latest revision. This is to ensure that the API deploy always gets to use the latest API design for deployment. In upcoming releases, there would be a way to update or refresh your older managed APIs into latest revisions after doing comparison between the two versions. Additionally, we will also support a lifecycle of a managed API from being created, tested, shared, to deactivated and deleted as part of the upcoming releases. So let's create a managed API on a published API by clicking on Create a Managed API gesture. This will allow deploy to review the operations in this API. For example, you can look at all these operations here. You can look at what policies have been applied to each of these operations from the designer perspective. For example, if you recall, we applied rate limiting policy on the designer side. Others, there was no policy defined. In addition to reviewing all the operations in this API, you can also provide the URL context, which is a unique name that would be used in the endpoint URL when this API is deployed. Let's give it a name called order management. This should be unique across all your API deployments. You can change the policies if needed at this point in time before deployment. For example, I can update the authentication policies to have a Jot token support because that's my enterprise-wide policy. In any case, you can follow the guidance based upon what is provided by the API designer. Let me also update the rate limiting policy. The API designer mentioned that we cannot go beyond this limit, but I think that probably we should go below this limit. So I'm going to make it 2 API calls in 60 seconds as a threshold. The rest of it, I'll leave it as is. For other operations, I will not make any changes. You will notice that there's an IP filtering policy available here. This policy allows for access control of managed APIs. An IP filtering policy lets you define a set of access rules that determines the IP addresses that are allowed to access or denied access, or rather blocked from accessing an API. Let's remove these policies for now and click on save. And we have an error. The context cannot exceed 10 characters. Let's make it smaller. You have to choose at least one authentication mechanism. So I'm going to go and mark them as anonymous for both of these to get rid of the errors, and then save it. And now there's no more errors. And now our managed API is ready. You can look at a managed API from the published API by clicking on the managed API account, which is a reference to the managed API perspective or tab, and filters it accordingly. Here you can see managed API with all its operations, and you can even download the Swagger file or the Open API spec to share with your end users. You also get to see what policies are applied on each of these APIs. Since this API operation needs a Jot token, we'll need to generate a Jot token to be shared with the users who would access this API through Jot authentication. You can do this by clicking on the Edit Managed API and generate a new Jot token here. You provide the expiration date and then generate new token and copy it and save it for future use. Let's get to a managed API. Let's download the Open API spec. I'll go to Postman and import this API spec. Let's update the request body, and let's try this without authentication. You notice it fails, says that API consumer could not be authenticated. So this is an authentication error because this API requires Jot authentication. I can go back and put the authentication scheme here and provide the Jot token which I copied earlier here and send a request, and this time it succeeded. If we try this multiple times, it will violate the rate limit policy. All these invocations can be monitored under the API monitor page. You can see a timestamp based entries here with the information on what endpoint was invoked, name of the operation, API name, applied policies, API version, status, and a short log. This helps monitor keep a tab on why an invocation failed and inform the right set of people. If I were to refresh it, you'll find the latest ones here. If you recall, the first call that we made was failed. It says port 1 unauthorized, and the subsequent call succeeded. Since this information can all be overwhelming, we are limiting this to show invocation for past 1 hour, 2 hours, 3 hours, or 4 hours. With upcoming releases, this will be augmented to show more information and not just for past 4 hours, and allows for a tool that helps API monitors identify patterns and hotspots so that they can inform the right people when there's an issue. This concludes my demonstration on the API Center, always open to feedback and suggestions on how we make it best suited for your requirements.